Section 4.3.27-T. The data in the table represent the weights of various domestic cars and their miles per gallon in the city for the 2008 model year. For these data, the least squares regression line is y hat, which is equal to negative 0.007x plus 45.464. A 12th car weighs 3,425 pounds and gets 12 miles per gallon. We want to, part A want us to compute the coefficient of determination of the expanded data set. What effect does the addition of the 12th car to the data set have on the coefficient of determination? So we're going to open up this data into StatCrunch. Okay, so let me go ahead and close that. So now here's our data, and what we want to do is figure out, okay, we want to add the 12th car. So if we add the 12th car here, we're going to put in the weight in pounds, which is 3,425, and it gets 12 miles per gallon. So with this data, we want to find the coefficient of determination, and we're going to round it to 1 decimal place as needed. So we're going to go to Stat, we're going to go to Regression and go to Simple Linear. We're going to make sure our x variable is the explanatory variable, which is weight in pounds. And the y variable is the response variable, which is the miles per gallon. Now let's go ahead and select Compute and determine what is the coefficient of determination. Well, let's go ahead and I'm going to copy this information with the expanded. Okay, so let's take a look here. All right, so there is our coefficient of determination. So here's our coefficient of determination. And so we want to be able to first so we're going to have 0.5415, and we're going to multiply that by 100%. Okay, so if we move this decimal over twice, we're going to get 54.15%. And they want us to round this to 1 decimal place. So that means we're going to have to round that 1 up to get 54.2%. So let's go ahead and put that result in here. So we're going to put 54.2% is going to represent the coefficient of determination of the expanded data set. And therefore there's our result. Now it says, how does the addition of the 12th car to the data set affect the coefficient of determination? So what we're going to have to do is, now we're going to go back and we need to figure out what is the coefficient of determination from the original data. So what we're going to do is, now we're going to eliminate this 12th, and now we're going to go back and do the same thing. We're going to go to Stat, go to Regression, select Simple Linear, make sure that we have the weight as the x variable, the miles per gallon as the y variable, and now we're going to select Compute. So now let's take a look at that coefficient of determination. So in this case here, looking at this new data set, okay, let's just compare this. So if we write this down as 4 decimal places, this is 0.8375, and we multiply that by 100%, then we would get 83.75%. Rounding that to 1 decimal place is 83.8%. So if you noticed, when we add that second point, it decreased the percentage. It went from 83.8% with the 11 sample size to the sample size of 12 to be 54.2%. So therefore, it decreases the what? The coefficient of determination. Okay. Now, in part B, it says, is the point corresponding to the 12th car influential, and is it an outlier? Okay, now, in order to answer the first part of the question, if it's a corresponding to the 12th car influential, we need to look at the equation here. Okay, and it's rounded to 3 decimal places. So let's go back to our data. Okay, in this equation here, we have y hat which is equal to negative 0.007x plus 46.197. Okay, so I'm going to go ahead and bring that equation down a little further here, and then I'm going to compare it to this equation here. Okay, so this would be y hat, which is equal to, rounded to 3 decimal places, negative 0.007x plus 45.464. And what we want to do is we want to compare the slopes for those two equations and the y-intercept. So when we take a look at the sample size for 12, there is the slope. And when we compare it to the sample size for 11, it is the same slope there. Okay, likewise, if you look at the y-intercept, it's plus 46.197. And for the y-intercept of the sample size for 11, it's 45.464. So what can we say about that? Well, we can say that the slope in the y-intercept did not change significantly, even though there was a change in the value of the coefficient of determination. Therefore, we're going to say that the added point is not influential. So that's the first part. So we're going to say, again, that the added point is not influential. Okay? So no, it is not influential. Now we need to determine, is it an outlier? Okay? So let's go ahead and look at that. So we're going to go back to our data. Okay, and then we're going to create a scatter plot. So again, we're looking at that 12th value, which was 3425, and then 12. Okay, and let's go ahead and graph this scatter plot. All right, so there is our x, there is our y, and then let's go ahead and make sure that we have our horizontal lines and vertical lines selected. Okay, so let's take a look at that point here. Okay, we're looking for the point where it says 3,425 and it gets 12 miles per gallon. So let's take a look at that point here. Okay, so there is that point. Okay, so this point here that has 3,425 and the y value is 12. Now, is that an outlier compared to these other points? Well, you can see this point is farther away than all these other points. So we're going to say that it is an outlier. So then we're going to select B, where it says, no, it is not influential, but yes, it is an outlier. And there is our result.